Good morning and welcome to another COVID edition of Science from the Basement. And if you're watching the 8th grade videos just for fun, you're probably going to see some of the same comedy, so please don't be offended. Just a real short lesson this morning on, as we continue through muscular unit, how muscles produce movement. This is not tough, okay? You guys already know this. Muscles exert force on, and what's at each end of a muscle? It's that really, it's fibrous connective tissue. It's kind of strong. Oh wait, I know, tendons. And then as a result, whoa, fancy, fancy, bones move. Okay, wouldn't it be nice if that was the end of the lesson, but you guys know me better than that. Let's take a look at how that really works in, I would say real time, but it's super fast. First thing you have to do is you have to have electrical stimulation. Where's that coming from? The nervous system in the brain. That's the excitability quality of the muscle tissue. And then as the muscle reacts to that electrical stimulation, muscles do the only thing they actually can do. They contract. And when a muscle contracts, what happens to that muscle? Everybody knows this. The muscle shortens. So that means the muscle itself, the muscle tissue, is physically moving. And that's on a microscopic cellular level. As actin and myosin interact, it's called the sliding filament theory. As actin and myosin, I know it's kind of weird, but this is how it works. You can read about it in your book or look it up online. We're not really going to teach muscle tissue in great detail. We want to stay with big muscles themselves. So you get electrical stimulation from the brain. The muscle contracts. The muscle shortens. As the muscle shortens, the muscle then pulls on the tendon. And you've seen this before. Although you can push things, muscles can only pull on tendons as they shorten. So as that shortening puts pressure and pulls on the tendon then pulls on what? Whatever it's attached to. And you guys know, for the most part, that's bones. It could be, muscles can be attached to other muscles and some soft tissue, but we're not really focused on that either. So when the muscle shortens, pulls on the tendon, pulls on the bone, and what happens? I don't know. The bone moves. And obviously we all take this for granted because even though you have conscious control, when was the last time you ever thought about, hey, I'm going to walk to the bathroom, and then you literally thought, walk, 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 walk. No one does that. So it's conscious, but it's kind of built in. You really don't, even when you move your hands when you're talking, like I just did right there, when you move your hands, you're not really thinking about it, although you are. So this is how it works. So this is the system to eventually get the outcome. How do muscles produce movement? There it is right there. Now there's one thing missing here though. When you look at when a bone is moving, don't forget, and I'll do a little drawing here, that muscle has two ends. Okay? It has two ends. So if the muscle is shortening, it will shorten towards its center line. Does everybody see that? So if it's shortening, the ends are going to get closer together. But if you were moving both ends at the same time, what you'd get is what, and I have no evidence of this is what it's called. I call it a washout. If both ends were moving at the same time, you'd get a washout. That means you'd lose power and control. Now, there are some very specific cases in which this can happen, but for the most part, it doesn't, and here's why. When you are trying to produce movement through a muscle contraction relative to a skeletal muscle and two tendons, okay, you're going to have two different ends. Okay, we'll call this end A, and this is going to be end B, and you can do this for any muscle. When there's a contraction, watch this. One end, in this case, we're going to call it end A, must stay still. It must stay still. If it stays still, then the other end, B, will be moving. So this end's going to stay still. This end will be moving. So if end A stays still, as this muscle contracts, you can see, and I'm going to do an overlying arrow here. The whole thing is going to be moving in this direction because this end doesn't move. So if end A doesn't move toward the center, then the whole muscle will move towards this end. I hope you understand that. Oh, sorry, let me make sure you guys can see all that. Crap. I was so excited about teaching that I forgot to move that up. Well, now you can see it. Okay? So again, part A, end A is going to stay still. Part B will be moving. The end that's staying still is going to be the anchor. Anchor, stay still. That end of the muscle is always called, and I'm telling you what, these are so important. You cannot understand muscles if you don't understand these next two words. This is called the origin. The origin is the end of any muscle during a contraction that stays still. The other end that's moving is always called the insertion. And this is such a fundamental thing in the muscular system. If you know this thing right here, the origin stays still and the insertion moves, then you always know what a muscle's going to do if you know its origin insertion. Because, and guys, remember this, I'm going to be harping on this from home in my basement for the next 2 weeks. The insertion can only move in one direction. That's it. It can only move in one direction. Does anybody know what it is? The insertion can only move towards the origin. That's it. Okay? So let me give you one little example. Let me pull this back down. Let me give you one little example. Okay? Let's say that the origin is there and the insertion of any muscle is here. So you can see the origin is above the insertion. So if I look at this concept, let me bring it back out, where the insertion is moving and the origin stays still and the insertion can only go to the origin, which direction will this insertion move on this paper? And I'll give you some options here. Will it go A, left, B, right, C, up, or D, down? So let's take a look at that little concept right there. And if you know this, if you learn this right now in the next 5 seconds, you will understand muscular contraction and movements for the next 2.5, 3 weeks. I'm telling you. If the insertion can only move towards the origin, all you have to do is do an arrow. Watch. The insertion can only move towards the origin. It's not going to make, when you look at muscle contraction, there's no turns. There's no spinning. There's nothing. It's straight line motions. That's why you have so many muscles, so that you have coordinated muscular contractions. Okay, well, look, if the insertion can only go towards the origin, which way is the arrow pointing? Up. In this case, it'll move in a superior direction. That's called elevation, and we'll do directional terms here in a bit. Okay, so that's the basics of how muscles produce motion. Now, for all of this to work, there is one missing key factor, and I'm going to end with this. None of this is possible unless your skeletal system in relationship to the muscular system can generate something that you've probably been learning for many years in elementary, middle school, and I guarantee you, if you have Mr. Ullman in physics, you already know this. For any of this to work, these two systems, the muscular system and the skeletal system, must be able to generate the big L. Dun, 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 dun. Wait for it. Big surprise coming. Who's already saying it in their mind or out loud? Looking at their phone or their computer screen? Leverage. None of this is possible without leverage. So guess where we're going tomorrow or the next day? Stay tuned. Because leverage can only be generated if you have a lever system. Look for that content in the next couple of days. Take care, everybody, and see you next time.